Hello everyone. Now today let us take the pH metric titration, in which we have to determine the concentration of X normal HCl using 0.5 normal standard NaOH solution. Now pH meter instrument is connected with the glass and calomel electrode, and in a beaker X normal HCl is taken and a burette is filled with the standard 0.5 normal NaOH solution. Now pH meter instrument shows the reading before adding any of the NaOH solution from the burette to HCl, that is 0 ml reading. It shows 0.52 pH. Now again 0.5 ml of NaOH is added from the burette and the pH meter shows the reading of 0.55 pH. So continuous addition of 0.5 ml from the burette is to be done, and after adding 1 ml the pH increases to 0.62. And 1.5 ml addition shows 0.67 pH. So we can see a continuous increase in the pH. See, 2 ml of the solution is added NaOH, it shows 0.74 pH. Again 2.5 ml of the solution NaOH added, it shows 0.81. So gradual increase in the pH is seen. 3 ml shows 0.95 pH value. Then after adding again 0.5 ml of the solution, it goes towards the neutralization. So acid is taken in a beaker, NaOH is a base added from the burette, and the neutralization process starts. It goes on increasing, which is shown by the gradual increase in the pH. See, 4 ml of the solution is added, which shows 1.23 pH. So it has little bit increased more. 4.5 ml shows 1.55 pH, and after that we will see the sudden jump in the pH value at the equivalence point. Now the pH meter shows the value 3.21 on addition of 5 ml of the solution. So gradually the pH is increasing because the solution is going towards the neutralization, and after addition of 5.5 ml of the solution the pH is now 6.12. We have to wait till the reading becomes constant. See, 6 ml of the solution is added and we are getting 7.86 pH value. Then after 6.5 ml shows 9.61 pH. 7 ml shows 10. So it is because of the base solution that is added from the burette NaOH, and hence the pH range is above 7. 7.5 ml solution, it shows 10 pH, 10.77. 11.35 pH at 8 ml of the solution. So this is after the neutralization point, and it is a sigmoidal curve. 11.63 pH at addition of 8.5 ml of the NaOH solution. 11.87 on addition of 9 ml of the solution, and now 9.5 ml shows 11.99 pH. And finally we are taking the readings till a constant sigmoidal curve is obtained. When 10 ml of the solution is added, the pH value is 12.07. Now we will plot a graph of pH versus volume of NaOH solution that is added. So in the graph we can see that on the x-axis we have taken the volume of 0.5 normal NaOH that is added in ml, and on the y-axis the pH value is taken. Now initially the pH of the solution is less because of the acidic solution. Gradually it increases on addition of a base because the neutralization process starts and the salt is formed. So pH goes towards the neutral. So salt is formed, that is neutral, and it increases till the complete neutralization point. So the middle point of this shows the increase, this shows the jump. We have added 0.5 ml of the NaOH, and on plotting the graph of delta pH upon delta V versus the volume of NaOH added, we can get the exact end point. So here, if we take the volume is in between, we can say this point and here, sudden jump is observed here, so it is around 7 pH. If we see here, the pH value is near about 7, so that is the equivalent point at the complete neutralization point. After that, on adding a base, there is no more acid in the solution now, and hence the graph shows the stable curve, that is the pH is due to the basic solution that gives above 7 value.